بسم الله الرحمن الرحیم. عرض سلام دارم خدمت دانشجویان عزیز. Hello students, I hope that you will be good. And now we want to start our course. We can wait at first for some minutes, for example 10 minutes, that all the students can come to the class, and then we can start our speaking about the course. Hello. I think we speak about this. We must speak in English because many of the students want me to speak in English in the class. Okay, now we can wait for. Is it possible to translate from English to Arabic through a college? Is there any student that translate my speaking from English to Arabic? Hello. Is there anyone? سلام وقت شما هم بخیر. متشکرم. Is there anyone that translate my speaking from English to Arabic? No one? سلام صبح بخیر. I will share the picture. Is there any students that translate from, for example, Farsi to Arabic? Is there anyone that I speak in Persian, in Farsi, and he or she translate it to Arabic? Is there? Then please students, please you must speak with yourself that if you want that I speak in English, I can speak in English. If you want that I speak in Farsi and one of the students translated to Arabic, I can speak in Persian. And unfortunately I can't speak in Arabic. If I could speak in Arabic, I will speak in Arabic. That will be that you won't have any problem. Then let me to disable my voice. You yourself speak with yourself and get decision. Okay, get a decision for all the class. Okay, no problem. Maybe one of you think that no need to translate. The others maybe think that need to translate. You must get a decision about it. No problem, no problem, because speech can't be translated later, and there is no one who is capable of translating from Persian to Arabic, and we are translating the lecture from translate. Okay, then if it is, I can speak in English, no problem. بله اگر سوال داشتین میتونین به فارسی بنویسید، مشکلی نیست. اگه جایی شما هم نفهمیدین آقای یوسر عمار میتونین به فارسی بنویسید، من برای شما میتونم به فارسی توضیح بدم. بسیار As I told you, I speak in English only for replying to the questions. If there is anyone that write in Persian, I can reply to him or her in Persian. Okay? خب پس این رو هم بگم، گفتیم ما به انگلیسی صحبت میکنیم. اگر کسی به فارسی برای من سوال بفرسته، من به فارسی برای همون جواب میدم. Okay, now let me to share my screen and start my speaking about the course. now you must have the image. Okay, as I told you, I speak in English and no need to any translation. Okay, now we want to start our course and our speaking about the Vhdl and introduction to Vhdl. As I told you, it is good for us to speak to have or to know Fpga implementation, and for Fpga implementation we need to know Vhdl. And now we want to speak about the Vhdl. Yes, this is really the second lecture. The first lecture was about the introduction to embedded systems, and this is the second lecture really. Okay. As I told you, I think that I told you that we have different implementation methods for an idea: software, hardware, microcontroller, and Fpga. All the implementations have some advantages and disadvantages, and the Fpga implementation specifically is very suitable for parallel computing and some good applications of Fpga implementation or image processing and artificial intelligence implementation and system development, especially for communication system development. And now we want to speak about the process of implementation. At first, let me to speak about the process of microcontroller implementation. Yes. Description language used to describe hardware, and we want to start about description the hardware. Let me write for you at first. Maybe you want to write for microcontroller. It can help us to learn better. For example, for microcontroller programming, at first you must write the code. For example, writing the code. For example, code vision, code wizard, Bascom for microcontroller. And then you must compile your code to be sure that your code is correct. And then you need to simulation. We have different methods for simulation. For example, we can use from Proteus as a good software for simulation. And after simulation, you must program your code to microcontroller. Program the microcontroller. And that's all. And your implementation process will be finished. But for Fpga implementation, we have other states. Fpga implementation. We must at first start by Vhdl coding, writing the code by Vhdl code. Then we must at first write the Vhdl, and it is the main step, and we must learn and understand the Vhdl writing or Vhdl code writing. The second step is compiling the code, and it is very easy for checking the syntax of the code, and then we must go to simulation step. Simulation step will be done in Vhdl, and we have some we have some methods for simulation. But really, maybe we have a Vhdl code, but this code can't be implemented on Fpga because Fpga implementation is different from simple Vhdl coding. Then we need a special step that check the Vhdl code, check that if this code can be implemented on Fpga or not. We say this step synthesis or synthesize. Synthesis, it means that checking the Vhdl code for Fpga implementation. Okay, after this step we will go to another step. We say this step implementation. It is really very similar to programming the microcontroller. By implementation, we implement or program the Fpga by Vhdl code, and this will be the final process. In some professional implementations we have another step here. We have post synthesis simulation. It means that we have after synthesis another Vhdl code. This is a special code that must be implemented on Fpga. We simulate this code, this new Vhdl code, for ensuring that this implementation is specially correct. Okay. Then for Fpga implementation, at first we must write Vhdl code. We must compile it to check the syntax. We must simulate it to be sure that the Vhdl code is correct. After this, we must check that the Vhdl code can be implemented on Fpga. It means that maybe we must have a Vhdl code that can't be implemented, can't be programmed, can't be really support by Fpga. Then in this step, synthesis, we check that the Vhdl code can be implemented on Fpga, or which must check that the Fpga can support this Vhdl code. Do you understand? Very good. And after the synthesis, we have another step, implementation. Implementation is like the programming. Implementation, it means that we program the FPGA by our code, by the Vhdl code. Then the last step is optional. We can do this or we can't do this. Do you understand, all of you? Okay, very good. Okay, we have some software for this process, only for this process. Let me to write, for example, for this process 1, 2, 3. For example, I can introduce you a software. It is very user friendly with name Active Hdl that support these 3 steps. And please, I will told you. And we had really some softwares that only support these 2 steps. Today we have some special software that support all of these steps. I introduced you to software that support all of these steps. The first one is its name is ISE. ISE is from a special company that focus on FPGA. ISE Xilinx. We have 2 main companies that work on FPGA. One company is Xilinx, and ISE is a software that Xilinx is prepared. This software support all the process from step 1 or all the steps from step 1 to step 5 or 6. Okay. We have some software that support some part of these steps or support all of these steps. One software that support only 3 steps, 1, 2, and 3 steps, 3 first steps, its name is Active Hdl, and the other is software from a special company with name Xilinx, with name ISE Xilinx. Xilinx is one of the main companies that focus on FPGA. We have many FPGAs from the Xilinx company. ISE Xilinx support all the steps from 1 to 6. And this software can be downloaded from the Xilinx site. You can go to the Xilinx site and then register your name and get the ISE Xilinx. The main drawback of this software is that this software is very heavy. For example, this software, is 16 gigabytes or 20 gigabytes. You need a good internet line to download this software. I will tell you very high speed integrated circuits hardware description language. Okay. Okay, then ISE Xilinx can support these steps, but ISE Xilinx only supports FPGAs from Xilinx company, and it is obvious. Okay. I will reduce my speed. Okay. Then at first, as I told you, we have a software that supports all these steps from 1 to 6. We say this software is ISE. This software is from a special company with name Xilinx. And this software can support only FPGAs from Xilinx company. We have another software. We say it Quartus. And this software only supports FPGAs from Ultra company. Let me to write this. We have some main companies that really made or fabricate FPGA. The main companies that fabricate FPGA are two companies. The first one is Xilinx. The second one is Ultra. Then you can see that we have two software that support all of these steps, and these two software is from these two main companies, Xilinx, ISE Xilinx, Ultra with name of the software Quartus. And Quartus only supports FPGAs from Ultra company, and ISE only supports FPGAs from Xilinx company. Xilinx is better because many FPGAs are from Xilinx. I think with my opinion. And you can download this software from Xilinx site. You can go to Xilinx site and get the ISE Xilinx from this site. you can download other programs and other softwares from this site. Okay. Then, do you understand all the speakings here? With my opinion, I think ISE is better. I think you can go. Let me to check from the internet live for you. As you can see, you can download ISE, you can download Vhdl, is another program from Xilinx. You can download other softwares and you can select the version. For example, 14 is one of the latest version. Okay. ISE Design Suite. Okay, and now you can download this. Excuse me. ISE Design Suite. Let me to check the download feature. For example, this download includes all the versions, answer, enable license solution center answers, and latest update October. Yes, you can select, for example, here Windows 7, XP several, and Linux split installer based, for example, like this, and 1.95 gigabyte. But it is better, and you can see file 1, 2, 3, and 4, and all of these files must be merged with each other to make the ISE. For example, like this. They are image, really. And after this, you will go to the sign in page of the Xilinx. You must sign in to the Xilinx and then get the software from the Xilinx. It is better for you to check, for example, latest versions. For example, this version is updated into any, and it is very good. And you can see that this file is 15 gigabytes, and if you download this link, you must at first sign in the Xilinx, and then and then download this software. Do you understand? Which repeat? Repeat the site. Mr. Muhammad Jafar. Repeat in the site, you mean? As you can see, let me to repeat it. Xilinx ISE download. Downloads in Xilinx. Select the version, and this is the file that you want to download. But at first you must sign in the page. Okay? I show that the steps. Another question. I think Mr. Yasser have one question. Mr. Yasser, if you have any question, please write it for me. Okay, very good. And Mr. Yasser? Mr. Yasser, do you have any question? Yasser Ammar حاتم اختلاف بین X یا text alter از فرق بین زایلینکس و ما بهش میگیم زایلینکس و آلترا، درسته؟ هر دوتا کمپانی، دوتا شرکت هستن که Fpga تولید میکنن. سهم بازار زایلینکس بیشتر از آلترا هست، به همین خاطر میگم ISE رو اگر شما بگیرید بهتره. فرقشون مثل فرق دوتا IC، دوتا محصول میمونه. از لحاظ عملی کرده کلی فرق ندارن، ولی تو خود مثلا امکاناتی که دارن، سلولایی که دارن، ممکنه تفاوت وجود داشته باشه. متوجه شدید؟ بسیار اوکی. Thank you very much. And now we want to continue our speaking in the slide. As I told you about the Vhdl, why we need Vhdl or why we need Hdl. Why we need Vhdl or Hdl? Because we need to model the complex digital systems and we need to test different digital systems. And we have two versions of HDL, hardware description language. The first one is Vhdl and the second one is Verilog. The first one, Vhdl, is in academic environments, and Verilog is a little industrial. Vhdl is the abbreviation of very high speed integrated circuits hardware description language. Okay, I will check my voice. Is it good? صدام ببینید خوبه؟ بسیار خوب. Okay. Then Vhdl is abbreviation of this, very high speed integrated circuits, for V. Hardware, H, description, D, language, L, and is Vhdl. And we have yes, we have different levels of design. Now we want to speak about the levels of design. There are different levels of design for digital systems. Each designer can work in any level of system design. For example, one designer can work on system level. The other designer can work on physical level. All levels can be mapped to other level. From physical level, for example, physical level can be mapped to logic level. Logic level can be mapped to register transfer level, RT level. RT level can be mapped to algorithmic level. Algorithmic level can be mapped to system level. And reverse order. System level can be changed to algorithmic level. Algorithmic level can be changed to RT level, logic level, and physical level. But what is the difference between these levels? We know that system level is a very high level. We speak about the system, the inputs, outputs, and its behavior. Algorithmic level, we speak about the main algorithms that are used in the system. In RT level, we must speak more specifically. Our speaking will be more specifically. It means that we speak about the system, we must speak about the register, we must speak about the transition between the data transition, we must speak about the data transition between different parts of the system, and something like this. The other level is logic level. Logic level means that we speak about the gates, the logic gates, and or, XOR, and etc. Flip-flops, and etc. And in the physical level, we will speak about the transistors of the system. Then we have different levels of design, and we can change these levels to each other. Okay. In Vhdl, we have these levels. logic level, RT level, algorithmic level, and system level. We don't have physical level because we don't speak about the transistors. And you can see that we have some domains of speaking: behavioral domain, a structural domain, and physical domain. What are these domains mean? Behavioral domain, it means that we speak about the behavior of the system. A structural domain, it means that we speak about the structure of the system. And in physical domain, we speak about the shape of the system, the physical of the system. For example, when we have in system level, from behavioral domain point of view, we speak about the system specification. From physical domain point of view, we speak about the chips and about the boards of the system. From a structural domain point of view, we have a connection between, for example, CPU, memory, and other main ICs. Another level, in algorithmic level, from behavioral domain point of view, we will speak about the algorithm. Which kinds of algorithms are used in the system? From physical domain point of view, we can speak about the main chips and the main blocks of the system. And from the structural domain point of view, we can speak about the processors and other subsystems of the system. From RT level point of view, register transfer level, we speak about the register transfer specifications in behavioral domain, about the macro cells in physical domain. Okay, it means that really these speakings means that we can write many programs for one system. Really, you must change your question. This chart means that we can write many programs for one system. For example, we have a one system. From a structural domain point of view, we have a special program. But from behavioral domain, we will have another program or another code. From physical domain, we will have another program or another code. And in different levels, we can have another program. In system level, we have one program. In algorithmic level, we can have another program. In logic level, we can have another program. Then these speakings mean that we can have many programs or many Vhdl codes for one system. Do you understand? All of you, all of the students, do you understand? بسیار خوب. Okay. Let me to speak a little in Persian. ببینید ما سطوح مختلف طراحی رو میتونیم داشته باشیم و شکل‌های مختلف ارائه میتونیم به صورت ساختاری ارائه کنیم، میتونیم به صورت رفتاری ارائه کنیم، میتونیم به صورت فیزیکی صحبت کنیم. خب معنی همه اینها این هست که برای یک سیستم میتونیم شکل‌های متعددی از کد VHDL رو توصیف رو داشته باشیم. کدهای مختلفی که در حقیقت نشون دهنده رفتار اون سیستم، حالا به صورت مثلا سیستمی، الگوریتمی، منطقی و امثال هم هستند. این در حقیقت معنی این صحبت ماست. پس به عبارتی برای یک سیستم میتونیم چندین مدل کد VHDL داشته باشیم. Okay. And as you can see, this chart is like Y in English. And we can have some transformation between different parts of this Y. We can have a transformation or transition from behavioral domain to a structural domain. We can have another transition from a structural domain to physical domain. We say transition from behavioral domain to a structural domain, we say this synthesis. It means that we synthesize the code or the system and change the behavioral domain to a the structure of the system. If we have a transition between a structural domain to physical domain, we have generation. It means that we generate the system physically. Okay. We can have a reverse transition. We can have a transition from physical domain to a structural domain. We say this extraction. And we can change the structural domain to behavioral domain. We say this analysis. It means that we have the system and we will reach to the behavior or to the equation of operation of the system. We say this analysis. If we transit in the domain, for example, transit in behavioral domain from different levels, we say refinement or abstraction. If we change from higher levels to lower levels, we say this refinement of the system. If we change from lower levels to higher levels, we say this abstraction, because behavioral domain in system level is very, very abstract. Then we say this abstraction. And if we change in a structural domain, in this structural domain from one level to other level, we say this optimization, because we really change the structural domain to get more specifications. Then we say this optimization. Okay. And another thing that I told you, Vhdl Design Process. We have an idea and we want to implement on FPGA. We have some steps here. Some little steps are like this: Vhdl entry or Vhdl coding and compilation. We will reach to netlist. After this, we have optimization and we will reach to optimized netlist. And after simulation and checking the simulation, we must implement on FPGA. In some cases, we say place and route beside on implementation. Why? Because architecture. Excuse me, I think that there is a problem, and this voice and the image, both of them have a problem. I speak many things, but the voice. Okay, would you please inform me about which slide the voice will be caught here? 7. Do you understand this slide? This slide needs speaking, yes? This? Okay. Okay, let me to speak about it. Vhdl design process. We have two design process here. It is simple and it is with some specifications. It is really the that I told you. It is simpler. Vhdl design process. We start by Vhdl code and compiling the code, and we will reach to a netlist. And by optimization, we will reach to an optimized netlist, and we must simulate the code. If we have simulation, a good simulation, we can pass from this step. If we can't have a good simulation, we must repeat these steps again and again. After this step, we have something like this: place and route. Why? We say sometimes implementation at place and route, because we have some cells on FPGA and we must specify the place of the cells and the routing of the cells in implementation. Then we can call implementation as place and route. In this slide, we have another Vhdl design process. In this Vhdl design process, we start by architecture design. We write the architecture of the system on a paper, and now we must write it in the Vhdl environment with the Vhdl code of the system. For Vhdl code of the system, at first we write Hdl design entry in Vhdl environment, and we need some test inputs. Then we need some test environment design. Both of them will be shape the behavioral simulation, the simulation of the system, and simulation that if this system can work properly or not. If the simulation won't be successful, we must repeat these steps. If it will be successful, we can go to other step: synthesis. Synthesis of the system means that, as I told you here, checking the Vhdl code for Fpga implementation. Then we check the code for proper implementation. After this step, we have implementation step. In implementation step, we implement the code on Fpga. Okay. After implementation, you can see timing analysis. Why timing analysis? Maybe we have some timing constraints. Maybe we have a special delay on the system that affect to the operation of the system. Then we need some timing analysis. And if we can't reach to our timing constraint, we must repeat these steps again. But if we don't have any timing analysis, or we can reach to our timing constraint, our implementation will be successful. Do you understand this? Okay. Okay, very good. And after this, we can introduce you a Vhdl book. This book here, now is known as a good reference book. Its name is Circuit Design with Vhdl by Volney Pedroni. We say it Pedroni's book. And you can download this book from the internet. It is very easy. I think this book has two versions, second version and third version, I think. And you can download the second version of the book. We can try this here if you want. These steps are really the algorithm or the main steps of working with Fpga. If you want to work by Fpga, you must do by these steps. Okay? Do you understand? Mr. Muhammad Jafar, do you understand? I mean, this talk is only for Fpga. Yes, is only for Fpga. Yes. Fpga. Yes, this talk. Yes, this talk is only for Fpga. And the reference book, as I told you, Pedroni's book, and we can check this book from the internet. Pedroni book, yes, here. Okay, and you can download this book. Please wait. Okay. Wally Pedroni, Digital Electronics and Design with Vhdl, and this is the book. You can download the book free and you can use from this book. Do you understand? Okay. And the last one is the Vhdl content. At first we speak about the Vhdl structure and some main things about the Vhdl environment. Vhdl coding, data types in Vhdl, and then Vhdl modeling methods, behavioral modeling and structural modeling. This step is very, very important. I think this step can take 1 or 1.5 months for us. And at the end we speak about the functions, procedures and packages in Vhdl. Okay. This is the second speaking of our class. If there is any problem, please write it for me. If not, we can end the class. Okay, no problem. Very good. If you have any question, you can write it in the class, or you can write it for me in private mode by WhatsApp. Do you have my number, my phone number? Do you have my phone number? No. Download the material. I can give you the material if you want by a flash. If you can come to my office and I can take you the material of the course. For example, the software and the book and my slides, all of us. And this is my phone number. If you don't have my phone number. Yes, this is the link of the download of the book. Okay, very good. خانم مروه لطفاً به صورت انگلیسی بنویسین. یه رو جا میندازه خراب میکنه. اجازه بدید صداتون خراب کنم. بفرمایید.
سلام، متشکرم. بفرمایید. میگن که تو این درس هم گزارش تهیه کنید.
سلام، متشکرم، بفرمایید.
این رو هنوز مشخص نکردم. اجازه بدین مثلا آبان ماه اون موقع بهم یادآوری کنید.
خیلی ممنون.
فعلا نمره
خواهم
درس
گفت.
آره اگر گزارشم اضافه بشه
فعلا نمره درس اگر گزارشم اضافه بشه
خیلی ممنون دکتر.
نمره گزارشم خواهد شد. خواهش میکنم. خب یه گروه هم تو واتساپ داریم. شماره من هم که من نوشتم الان شمارمو. اینم شمارم. سوال ها رو خواهم گفت. هنوز خیلی مونده تا آخر ترم. نگران اون نباشید. فعلا سعی کنید درس رو خوب یاد بگیرید. بعداً در مورد سوال ها هم صحبت خواهیم کرد. یک نمونه سوال هم به شما خواهم داد که بدونین سوال ها چجوری طرح میشه. بسیار خوب. نمره ها رو گفتم فعلا چون گزارشی چیزی ندادیم و مطرح نکردیم فعلا یک پایان ترم هست. تمرین یا احیانا سوالاتی که در حین ترم ازتون میپرسن به عنوان فعالیت کلاسی اینها نمره شما رو میسازه. اگر که تحقیق هم یا گزارش هم بهتون بدم اون هم جزو نمرات شما خواهد شد.
اینا رو بگم بعد.
الان یه نفر نه یه نفر الان پیام داده که کی پیام داده به من الان؟ یک نفر پیام داده که وارد زایلینگ شده نتونسته دانلود کنه. متشکرم. Is there anyone to want to download the ISE and there is a mistake in this? Which one? Which one of you? Okay. Okay. Are you in Iraq or in Iran? I will send you to review this. In Iraq, because I think name and address verification it is related, I think, about the I think it is better for you to use anti-filter, because I think that the website of Xilinx is sensitive to some countries. I hear that it is sensitive to Iran country, but if you want, you are in Iraq, I don't know. Maybe it is sensitive to Iraq, maybe. Okay, Mr. Yasser Abdul Karim. It is better for you to use at first from anti-filter or VPN, and then go to website of the Xilinx. Okay, very good. Okay, no problem. Then thank you and goodbye.